Hello, Stats 300, and this is Professor Gonzalez, and I would like to do some more problems. And now this is from section 8.1 in the interactive ALEKS side of things. Okay, so we just have two of these on 8.12 questions that come from this on the interactive side. In fact, when you see this in the grade book, or when you're looking at this in the pull down tab, there are only three questions, I believe, that you have to do. Two in 8.1. I think there's just one in 8.2. Anyhow, let's take a look at this one. It says, question number 1, the mean diastolic pressure, blood pressure, for a random sample of 150 people was 96. Now, maybe we put some color on that. They're already talking the mean, so the mean blood pressure for a random sample of 150. So right there, we already know that N is 150, and they're talking about a sample. So this mean value right here is not the population mean. This is the sample mean. So we need to use the proper notation as X bar. Okay, then it moves on to say, let's see, if the standard deviation, if the standard deviation of individual blood pressure readings is known to be 10 millimeters of mercury. So the standard deviation, so if the standard deviation of individual blood pressure readings is known, then we know that this is actually coming from the population, because it says it's known. It's not coming from the sample. If the standard deviation of individual blood pressure readings is known to be, so that is going to be a standard deviation from the population is known. And I think I'll put population here. Right, and this stuff in red I've got is the sample information. Let's read on. Then find a 95% confidence interval for the true mean. So for the true mean, well, that true mean they're talking about is the population mean. Diastolic blood pressure for all people. Then complete the table below. So it's not really a table. Basically, we're just trying to find the lower limit, the lower bound of this. So remember, we're trying to find a confidence interval. So we don't know the exact population mean. So we're going to make an interval. We're going to find a number that says this population mean is going to be between this low number and this upper number. Okay. So really good idea to go down to our formula sheet, confidence interval. Now this is confidence interval when you're trying to find the population mean when standard deviation is known. And remember, in that problem, standard deviation was known. It was given to us. So we're going to use this formula right here. And like last time when I did 8.1 from the assignment side of things, I kind of broke it down for you a little bit. So let me do that again. And this formula is great because it really shows all the little pieces. These two numbers are the same thing, and those two numbers give the will give the marginal or I should say the margin of error. Let's just say it that way. The margin of error. Okay, and what is this little piece over here? Well, that is just the sample. That's the sample standard deviation. Sorry, the sample mean. That's just the sample mean. And then what is this value right here in the middle? That's what we're trying to approximate, right? We're trying to approximate, trying to figure out this population mean. Right, and we're trying to say, we don't know what this population mean is, but we're going to use a procedure that gives us a certain level of confidence that this population mean is bigger than this number and smaller than this number. And so you've got a lower and an upper bound or limit, okay? All right, so let's take that information and use it up here. Oh, there we go. And what I'm going to do is I'm just going to rewrite that. So that just says x bar, oops. That just says that x bar minus my margin of error, which is that the z-score for half of alpha, which is called our critical point, or critical value rather, and then our standard error is going to be sigma divided by square root of n. So my mu is bigger than that, and my mu, population mean, is less than this, which is taking the sample mean plus my margin of error. Okay, let's write down the things we know, and you can see up here we already have some of this stuff figured out. I've got my population, standard deviation, right? And then we also had a bunch of information from the sample. Sample size is 150. We also had our sample mean to be 96, and we're going to need to get our. What color am I going to make this? I don't know, brown. We're going to need to get our z-score from half alpha, which is called our critical value. Now, the critical value is going to be based on a confidence level of 95%. So I'm going to put 95% there, and I think I want to put that in parentheses. So a critical value for 95%, we can calculate it like we did on problem number 1 of assignment 8.1, but better yet, if we have this 95% confidence interval in a chart, we can just grab it really quick. Let's see. 95% confidence level. And we look at the bottom of this, and the 95% confidence level has a z-score, also known as our critical value, half of alpha, of 1.96. 1.96. Okay, I think we're almost ready to fill in some information. Before we do this last bit here, I think it'd be really nice for us to figure out actually what this margin of error is. Once again, we know the margin of error is just going to be found by multiplying our critical point, which is 1.96 times, and I didn't figure that part out yet. Let's see. Gosh, I don't know why I feel like I'm running out of color here. Let's go with, is yellow hard to see? Let me go with purple. So I need to figure out this piece right here. I should have done that over here. So this piece is just going to be the standard deviation, which is 10. That's the population standard deviation, divided by the square root of my sample size, which is 150. And let's see, when we calculate that, we're going to get an approximation. We're going to round to, let's round to 4 decimal places, 0.8165. I think that rounded up. So that's going to be 0.8165. That'd be an 8. All right, well, when we go ahead and multiply that, we get a margin of error of approximately 1.6003. So there's our margin of error. And this is really going to help us to figure out our upper and lower bound, because the other piece we want is our sample mean, which is 96. So our sample mean is 96, which is this guy. And we have our sample mean over here, which is 96. So how do you find the lower and upper bound with this margin of error? Well, it's just going to be, to find the lower bound, it's the sample mean minus my margin of error. So when I do that, what is that notification? Get out of there. Okay, so now we have, when we subtract that, we get 94.3997. And then when we want to figure out our upper limit, or our upper bound of our confidence interval, it's 96 plus the margin of error, which is 97.6003. So there's our lower, and here's our upper. Now they wanted us to round to how many decimal places? Round your answer to 1 decimal place. So yeah, it's pretty crowded up there. But if I did that, I guess I'll do that in red. That's going to be, for your lower, that's going to be 94.3. And the upper is, so the lower is right here, and we rounded to 1 decimal place. And the upper is 97.6 is from the upper. So we have completed, we have completed our confidence interval at a 95% confidence level. There it is. Okay, next question. A scientist studying babies born prematurely would like to obtain an estimate for the mean birth weight. So this is basically the whole procedure of confidence intervals. This is the population mean, right? That's the population mean of babies born during the 24th week of the gestation period. She plans to select a random sample, so there's going to be this random sample of birth weights of such babies, and use the mean of the sample. So what's the mean of the sample? The mean of the sample, the mean of the sample, when they're saying that, they're just talking about these X bars, to estimate. So they're using the mean to estimate the mu, the population mean. Okay, that's what confidence interval is. It uses the sample mean to give us an estimate. Now, this is a point estimate, right? This is 1 point. So we want to be more confident by making an interval and saying, so how do we make this interval? We make the interval by using this formula that we just used right here to make our interval. Okay? That's not what this question is asking, I don't think. Let's see. Assume that the population of birth weights of babies born during the 24th week has a standard deviation. Okay, so now we know the standard deviation. Let's write that down here. Has a population standard deviation of 2.7. What is the minimum size needed for a scientist to be 90% confident that her estimate will be within? Okay, so we've got all these little pieces. What's the minimum sample size? So really what we're looking for on this problem is n. How big of a sample size do we need to make in order for us to have a 90% confidence level and be within 0.4 pounds? Well, that's called a margin of error, right? 0.4 pounds. So 90% confident. So let me move this down because I think I want to have some space here. We'll make this, I don't know, make that blue. Want to be within 0.4, so a margin of error of 0.4. Now the reason why I just made some space is because what goes with a 90% confidence level? Well, the critical value goes with that, right? So I'm going to look up a 90% confidence level on my chart, and hopefully it's there. And let's get rid of all that. So a 90% confidence level has a z-score of 1.645. Okay, so now how do we do this? Well, we actually have a formula. You could use part of the you can use the formula that we are using to find the upper and lower limits, but this book is nice and they actually solve for n and give us this nice little formula that basically does it for us. Notice we have our point, our critical point, we have our population standard deviation divided by our margin of error, and that gives us n, how many, the sample size we need, okay? So it's really pretty straightforward from this point. You just have to know where to find all these little pieces. And we have, this is, let me put up the formula for us. So this is our z value from half of alpha, which is called the critical value. This is our standard deviation from the population, and is divided by the margin of error, and that whole thing gets squared. So here's what we have. We have a critical value of 1.645. We have a standard deviation, let's go ahead and make that green right there, of 2.7. Okay, so those two pieces get multiplied, then they get divided by our margin of error, which happened to be blue, 0.4. And then after you divide, so you multiply the numerator, then you divide, and then finally after that you have to take the square. So when I do the math on the inner part of this, I get 11.10375. Then I go ahead and square that, and I get approximately 123.2932. Okay, now remember, this is a sample size, so we're usually sampling people or things that are going to be usually integers or whole numbers, that kind of thing. So I mean, we're talking about babies here, right? So you can't have 123.6 babies. Now, if someone said round this to the nearest integer, you might say I need to round down to 123. But the problem is, if you round, oops, there's that freezing thing again. And I think I figured out how to unfreeze by doing that. There we go. So the problem is, if you round it down, as you might normally do here, if you round it down to 123, the problem is that that's not a big enough sample size to get this margin of error, right? 123.29 will do it. So since we need a whole number, or an integer, I should say, we better round that up, even if this is typically rounded down. Okay, so we need a sample size of 124. And I'm going to say that's for a 90% confidence level. And what? And a margin of error, of error at 0.4 pounds. So what sample size do you need? You need a sample size of 124. Okay, I hope that helped, and I hope people are starting to see the connection here. These problems that I'm doing from the interactive side, the interactive side matches up with test part 2. The questions are the same questions that I'm doing that are going to the part 2 test, and the assignment side that I've been doing also, that lines up with the test part 1. Okay, I hope you're having a great day. I hope everybody's safe, and take care.